This is the example 3 in section 4.3. So we want to determine the derivative for the function f of x equals x plus h divided by 2x plus 1. So the first thing we're going to do is write the definition of the derivative, which is f prime equals the limit as h goes to 0 of f of x plus h minus f of x divided by h. So we're going to do some algebra to the side, and then we're going to substitute back in our terms. So the first thing we're going to determine is what is f of x plus h. So f of x plus h, you are replacing x with x plus h. So in the numerator you would get x plus h plus 3, and the denominator you would get 2 bracket x plus h plus 1. So you would then multiply the denominator, so you get x plus h plus 3 over 2x plus 2h plus 1. So I'm going to substitute that back in and write it out. X plus h plus 3 over 2x plus 2h plus 1. Then I'm going to subtract the original function, which is given in the question. X plus 3 over 2x plus 1. Now I have to divide all this by h, but I'm going to multiply by the reciprocal, which is 1 over h. It just makes it look tidier, and you can see the h cancel in the end a little bit better. So I have to subtract these fractions, so I need a common denominator. I have a trinomial and a binomial. So what I'm going to do to get a common denominator is I'm going to combine them. So I'm going to have 2x plus 1, 2x plus 2h plus 1 as my common denominator. And I'll do the same thing for the second term. So we're just going to write that down. So there's a bit of writing terms down. Still got a 1 over h. So now I'm going to find my new numerators. So I know in this denominator I am missing a 2x plus 1. So I'm going to multiply this numerator by 2x plus 1. So I'm going to write 2x plus 1 times the numerator. In this denominator, I'm missing that trinomial, so I'm going to multiply this numerator by the trinomial. And then I'm going to expand my terms and see if anything cancels. So I have the limit as h goes to 0. This is f prime of x. And let's see what we get for our terms. So when we multiply out, we're going to expand all our terms out. We will get 2x squared plus 2xh plus 6x plus x plus h plus 3. So that's your first numerator minus, now I'm going to multiply out these numerators, So I'm going to get 2x squared 2xh plus x plus, now use the 3, 6x, 6h plus 3. Run out of room here. All over my denominator, 2x plus 2h plus 1. And don't forget that I have a 1 over h here that I'm going to squeeze in there. Okay. So I have a lot of terms in the numerator. So let's see if I have any terms that cancel. So I have a subtraction here, so you have to remember that this subtraction is going to go through all these terms. So this 2x squared here is negative. So this 2x squared will cancel with this 2x squared when you subtract. This 2xh will cancel when you subtract. 6x and this 6x will cancel, and I'm left with this 3 canceling. As you can see, this x is canceling, so then I'm left with, in the numerator, h subtract 6h. So a lot of terms went away. So I'm just going to write this out again. So now you notice that you have like terms in the numerator and you're left with negative 5h. So I'll write the denominator one more time. And I will notice that the h's cancel, which that's your goal. And then you're left with the limit as h goes to 0 of negative 5 over your denominator. So now we're going to apply the limit. So as h goes to 0, I am left with negative 5 over 2x plus 1. H goes to 0, so I'm left with another 2x plus 1, which is equal to negative 5 over 2x plus 1 squared. And this is your derivative, which represents the slope of your tangent line for any value of x. For any value. For any x value. And that's it.